Okay, so we're going to draw an example of a liquid with the molecules inside. So try your best to draw a glass or cup. Now in a liquid, the molecules or particles, those words kind of mean the same thing. So you'll hear me say both. Particles, molecules. They are spread apart and flowing around freely. Okay, they're moving, so I'm just going to draw these little lines around the outside to show that they move. They're not packed tight. Now when we have a liquid and we heat it up, so we add heat. Let's think about what happens to that liquid. Let's just say water is our liquid. We're going to use that probably for all of our liquids to talk about. If I heat up a liquid, like say I'm boiling water on the stove, I'm heating it up to make macaroni and cheese or boil some potatoes. What starts happening to that water? And what do you notice? Kaylee? It evaporates, she says. Very good. So what do you start to see, Kaylee? I mean, Kelsey?
Gas.
Gas. What do you call that? When you see it coming up from the pot, what do you typically say? Oh, Mom, I see such and such coming up from the pot.
Vapor.
Vapor. Sometimes we may call it what else?
Water vapor.
Water vapor. Steam. Very good. So that's what we're going to draw on the inside. That liquid, if we heat it up, we add heat, it's going to change into a gas.
Yes.
So the new state is going to go right here.
Wait, you want us to do the line inside?
You can if you want. Yeah, it'd probably make it look a little bit neater if you go ahead and draw the lines on the front, on the inside too.
I did.
Okay, so the new state is a gas.
Well, I'm trying to get some tissues because I have room.
Okay, now we're just going to draw
Well, yeah.
the particles of a gas are even more spread out than a liquid. Okay, now over here we're going to put example. And you guys just told me several examples. You said steam, you said water vapor,
Gas.
we talked about the pot boiling on the stove. So that's what we're going to draw as our example. And what we call that is evaporation. When the water starts steaming, it's actually evaporating.
Are you putting this in the hallway?
No. This is probably, that we're going to glue this in our science notebooks. We're going to add to this every single day this week, so you need to keep up with it. This is just going to be the first one we do today, because tomorrow I'm going to show you how water evaporates and changes into a gas.
Is it going to be exciting?
Can anybody think of another example instead of a pot on a stove of evaporation or water liquid changing to a gas? Gregory?
Maybe Maybe if it was getting hot and it was getting very hot and snow would evaporate.
Okay, snow would melt first, but then once it turns into a liquid, eventually it would evaporate. Good. So when it rains and you see a puddle out on your driveway or out on the road, and then the next day it's not there, or later in the day it's not there, it didn't just sink into the ground, did it? What happened? Some of it will evaporate up. Some of it might sink into the ground, not concrete, but your grass or your yard. But the rest is evaporating, okay? Yes, ma'am.
Okay, so and when it evaporates up, it leaves like mud. It leaves mud on the ground.
Yeah. So what do you think would happen if I left this pot of water on the stove and I forgot about it? And it just kept boiling and boiling and boiling. What would eventually happen, Evangeline? Yes, you would have no water left. Okay? So the longer you're boiling that water, or the longer it's getting heated up, the less water you will end up with. Okay? You could even boil it to where there's no water left. Okay? You don't want that to happen either, because it will ruin your pot. Okay, so we are going to add more to this tomorrow, but for today we are done. So you guys can put this in your work in progress folder, and we will continue the second box and the third box tomorrow.